All right, so hello and welcome back to the continued coverage of the walkthrough series. And in this episode, we are looking at the October-November 2023 9618 variant 43 paper. And in this video, we are looking at the Java implementation for question number 1. All right, so the question here is going to be, actually, it's not going to be using the text. I think it's for number 2 right there. Oh, yeah. So the question here starts with this iterative vowels function implemented in pseudocode, and we are to write program code that basically implements this iterative vowels function, as it were. So of course, you can always pause the video or open a copy of this paper on your own and just read through the entire question. But I'm not going to read everything else. But basically, the whole idea behind this iterative vowels function is to count the number of variables, rather the number of vowels inside of a given word. Is it so? Let's actually go ahead and look at that implementation in Java. So you see that I have my function header on line 6 that essentially matches the function header right here on the in the pseudocode implementation. Is we are going to take a string with an identifier of a value. Then we are also going to return an integer. So you see that the return type here it's integer. Then our string is called value right here on line 6. Then we are going to need somewhere to store the total number of integers that we come across inside of our string. So you see that we have this int total going on right here on line 7, and we are initializing it to 0 because before the algorithm runs, we do not have any vowels that we've accrued to the total, as it were. Then of course we are going to check the length of the string. They actually did that here in the pseudocode right there on line. That would be line 1, 2, 3, 4, 5, 6 on line 6 of the pseudocode right there. So we are going to check the length of the string right here. Then we are going to have a loop that's going to run for as long as the length of the string, is it? So if our string is 5 characters long, then our loop is going to run 5 times. So that's essentially what we are doing on line 10, initializing a for loop. And then on line 11, we are slicing the string. Basically, we are taking the character that is at the first index position. That would be index position 0 right here. So that's why you see we are saying index 0 there. So we are taking that character, then storing it as the first character. Then in the case that the first character matches any of these vowels, that is the A, E, I, O, U, then we are going to increment total by 1. Then we break out of the loop. So essentially, remember, this loop has been set to run for however long the string is. So if the string is 5 characters long, then we are going to move on to the next index position, then check to see if the next character is actually going to be a vowel. Then we are simply going to repeat that for however long the word is, and then each time we are just accruing the total right there on line 19. Then of course, after having counted and recorded a particular vowel, we are simply going to slice the string. Is like, for instance, let's say we are looking at, if you look at this remove keyword that I have going on my comment on line 22, after having sliced R right there, we are going to be left with E move, is it? So, right, that's what we are doing on line 23 there. We want to begin at the next index. So essentially, we are now moving on to index number 1. So that's what we are simply doing, slicing the string, as it were. And in Java, the way you can slice a string is to use the substring, and you can actually see the documentation right here when I hover over this substring method. Here's an example. If you say unhappy.substring 2, then you're going to slice the string starting at index position 2. So you need to remember that this is 0, 1, 2. So it's going to start at H and give us the string happy. So yeah, that's the implementation for the iterative vowels function. And of course, you would be done with the implementation, and it's worth 5 marks. So you'd of course go ahead and copy the code and paste it inside of the evidence document. Then moving on to part B, rather part A, item 2. We are to test our iterative vowels function by passing house as a parameter. So let's actually go ahead and do that right here. So you see that I have the main method right here between lines 28 and where's my closing brace, line 40 there, is it? So that's my main function right there, lines 28 to line 40. So we need to test iterative vowels having passed house as a parameter. So then after which we need to present how many vowels are inside of the string house. So item 3 requires us to test the program. So let me just go ahead and click on run here. And you should see that we get the count of how many characters are, rather how many vowels are inside of house, and it's actually 3. So you would of course go ahead and copy this code, take a screenshot of the output and paste it inside of the evidence document. Then moving on to item B, rather part B, item 1, we are to implement iterative vowels but recursively this time around. So, and it's worth 6 marks. So let's actually go ahead and look at the implementation that I have going on here. So for any recursive solution that you are going to come up with, you need to remember that you have 2 conditions that you need to satisfy. So the first condition is to have a base case, right? Sort of like an exit strategy. So the base case in this case is that we need to terminate the loop, or terminate the recursive function or the recursive solution by checking to see if the string is empty. So if the string is empty, then we're not going to return, we're simply going to return 0, and that's essentially our exit strategy. Then the second thing that you need to do is to have a way to work towards the exit strategy, is it? So the way we are doing that, it's the rest of this particular code block right here. You see that we are testing to see the character at the current index position. Initially it's 0, right? Then if it matches any of these, we are just going to set count to 1, then we break out of the loop. Then should there be no vowels in the word, as it is simply going to return a default count of 0, is it? So this is how it's going to work towards the exit condition. And also we're always going to return the value of count plus recursive vowels. So remember, recursion, it involves a function calling itself repeatedly until it gets to the exit condition. So when it gets to this part, right, it's going to take the value of count. Let's say if the word was maybe say count, right, you'd see that there's no C is not what is not a vowel, so it would return a value of 0. So count would actually be 0. Then it would slice the string right there, because you see that we are slicing the string inside of this function call right there on line 61, is it? So you are passing the substring of the word count, as it were. I'm just using count as an example in this case. So we would actually be having OUNT, is it, as being passed as an argument to the recursive vowels. So essentially, it's just going to call itself repeatedly until it solves the solution, or until it gets to the base case, as it were. Then by that point, or by that time, count would have a value of all the vowels that are inside of the particular word. So that's how you can implement it recursively. So let's go and look at what we need to do next. So we have to test our program by passing imagine as an argument to the function. So let's go to the main function right there. So you see that B item 2, we are passing imagine as a value, as an argument. Then we are storing the result inside of this result variable. Because remember, recursive vowels is going to return an integer result, as it were. So we are going to store that inside of this integer variable we called result, right? Then we are simply going to output the result, as it were. Then B item 3, we are to test our program and take a screenshot of the output. So let's come here, press on the run button, and you see that we get vowels in imagine. It's 4, is it? So this one is for the iterative output, this one is for the recursive output. So having done that, you can go ahead and take a screenshot of the output and paste it inside of the evidence document. And yeah, that's just about it for this episode. Hopefully you learned something, and I'll see you guys in the next one.